Hello, everybody. I'm Dr. Shafiq. I am your instructor for your geotechnical class. I would like to welcome all of you in this video session. Today in this video, I'm going to show you how to solve some of the problem from weight volume relationship. Okay. In the first video, you already saw the concept and how to develop all those equations, everything. In this particular video, I'm just going to discuss only about how to solve problems. Okay. Now let me share my. So here is the first page for weight volume relationship problems, right? So if we get like a soil, partially saturated soil, most of the cases soil is partially saturated, then you see like three uh, phases of soil. One is like solids, then water, and then gas. When the soil is saturated or fully saturated, or saturation is equal to 1 or 100%, then basically you can see there is no gas or air present in the soil. All the pores are filled with water, and we call that one fully saturated soil. On the other hand, when soil is completely dry, means like there is no water there because of, let's say, warm weather and high temperature, all the water can be evaporated, which is basically very difficult to do. Um, Actually, in natural condition, it's very difficult. Like there should be at least 2 to 3% water all the time there. Anyway, so theoretically, when you take all the water out from there, then basically we call that one dry soil. Okay. Now, if you take like a known volume of soil, and you can see all the three phases present here, and some sort of magical way, if you try to get all the three phases separately, then you can show that one here. Like this is your V, means like volume of solids, this is volume of water, and this is the volume of air, and this is actually your volume of the void. Okay, so some part of the void is filled with water, some part is filled with air. Now, one of the assumption we always take that the weight of the air is 0. Okay, um, and then this is your weight of water, and this is your weight of solid. Now you can ask me this question like, how can I find out the weight of the solid for a particular volume uh, of soil? Well, you can keep that one in the oven for 24 hours at a temperature like 103 or 104 degrees centigrade, and then you can find the oven dried soil which doesn't have any water. So if you take the weight of that water, that's basically your weight of solid. Okay. Now you can ask you, how can I find out the volume of solid? Oh, well, um, you can do that one by, like make that one completely dry, and then let's take a beaker and put that one known amount of water, let's say 1 liter, and then you add some soil there. You will see the volume of the water will rise a little bit. And actually, if you take all the air out from there, then basically you will get the volume of the solid, right? So that's the way we can find out, like that each of that thing in practical situation. Similarly, how can you find out the weight of water? So you take the weight of the total soil and then keep that one in the oven for 24 hours at a temperature of 104.5 degree, and then take the weight of the soil again, and now all the water is gone. So the difference between the initial and final weight, that's basically your weight of water, right? So basically, there are a lot of ways that you can find out this weight of water, weight of solid, volume of solid. And volume of water is very easy to find out because you already know the relationship that um, let's say 1 feet cube of soil has 62.4 pound weight. So if you know the weight of the water, then basically you can convert that one to volume of water. It's very easy, right? Now let's move forward. So the weight volume basic relationship, you have to remember that what is what, okay? Now let's say the first thing is your void ratio. So what is void ratio? That's basically E, which is VV by VS, okay? VV divided by VS. That's your void ratio. And your porosity is basically VV divided by total V. Okay, that's why your porosity is always smaller than your uh, void ratio, because V is always bigger than your VS, right? Now, you can see this is your degree of saturation, which means like how much volume of the void is filled with water. If the whole void is filled with water, then your degree of saturation will be 1. If none of the volume of water is 0, then basically your saturation is 0. Okay. Now there is a relationship between void ratio and porosity. If you know that relationship, like that would be much easier for you to, convert that one from one to other. So your porosity is basically void ratio divided by 1 plus void ratio. Similarly, if you want to find out your void ratio and if you know your porosity, then basically your void ratio is equal to N divided by 1 minus N. So N is the porosity and E is the void ratio. Now let's see the other way here in terms of weight. These are kind of volumes, all the volumes here, right? Now, if you come here, the most important part would be water contained. What is water contained? That's basically weight of water divided by weight of solid. Okay, weight of water divided by water of solid. Very careful that many times I see that students will confuse with weight of water divided by the total weight. No, that's not your water content. Your water content is the weight of solid divided by the weight of water divided by the weight of solid. Now, moist unit weight. Moist unit weight is the weight divided by volume, which means like the weight per unit volume, right? If you know your total weight here and your total volume here, if you divide this with this, then basically you get the moist unit weight. Then dry unit weight. Dry unit weight is only like the weight of solid divided by your volume, because many times you understand that the water will go away from the soil. So the only thing that remain there is the weight of solid. That's not going to change until you change your compaction. So we'll talk about compaction in chapter 6, but for now, you have to just remember that your dry density is basically, dry unit weight is basically weight of solid divided by the total volume. Now, there is a relationship between, like moist density and the dry density. And what is that relationship? Your gamma D is basically gamma divided by 1 plus W. W is your water content. Okay, if you know your water content, basically you can find out your gamma D from there. And finding water content is not that difficult, as I said earlier. The way we do that one, we take a can and take the weight of the can, okay? Then we put some soil there, sample soil there, moist soil. Take the weight of that soil again with the can. Then we put that one in the oven, let's say for 24 hours. At a temperature of 105 degree, 4 degrees, more than 100 degree, I will just say. Then we'll take the weight of the dry soil. Now, if I take the weight of the, like can out from there, then basically I can find out the weight of the solid. I can, by subtracting the 2, I can find out the weight of the water. So if I know the weight of the water and divide that one with the weight of solid, that's actually the water content, right? So that's the way we find out our water content in most of the time. Now let's move forward, but you have to remember this basic relationship, like to do your problems. Okay. Now we can solve these problems two different ways. One is, let's say, if I know the basic parameters, what I told like in the earlier page. Like, let's say if I know all the basic components such as VS, VV here, if I know VS, VW, VA, WW means like weight of water and weight of solid, then basically I can find out anything from there, right? Now, this method takes a little bit more time, but it's good for understanding. So you can do some of the problem like following the basic rule. And then the second method is actually using weight volume formula. There are some formula given in your book, which you can develop easily. Uh, and some of the relationship has already been talked about in the earlier video. So you can take a look how they develop that relationship. If you have that relationship, or if you can remember that relationship, then basically you can do that one easily. The advantage of this method is like it's much faster because you don't need any figure. You just use the formula to do that one, okay? So if you are familiar with that formula and practice a lot, then basically this one would be the best way to solve your problem for any FE type question, because time is very important for FE exam, and maybe for your exam for this course, because we are going to follow the FE exam format. Okay, so I'm going to show you both methods, that how you can do this one, this method, and how you can do the same problem with using the formula. Okay, now this one, as I said, like it doesn't require any figure, so it would be much faster. So this one is slower, it's faster, but this one is good for basic understanding. This one, um, you don't need to know like each of that term separately, and you can just find out directly what you are asked to find out. Okay. Now let's say uh, the how we can solve some of the example problems. Okay. So now the first thing is like how you can just follow the first method. Okay. So the first method is basically to find out all the 5 parameters, not 6, because we assume that the weight of air is 0, right? Now, the first rule is if your volume, if your unit weight is given, either saturated unit weight or moist unit weight or dry unit weight, then basically you assume that the total volume of the soil is 1 unit. So you use this figure here, okay? This figure here, and you assume the total volume is basically 1 unit. Let's say 1 feet cube. Then by definition, the weight of this one has to be equal to your unit weight, right? So since the unit weight is given, so you already know what would be the total weight here. And if the dry density is given, which means like your weight of solid is actually given, okay? So basically we do that one, and then you can see from here, we try to, if our water content is given, then we can find out our weight of solid, because that's gamma divided by 1 plus W. And you find out the weight of water, that's actually water content multiplied by weight of solid. Once you know the weight of water, then basically you can find out the volume of water just dividing that one with the unit weight of water. And we know the unit weight of water, which is 62.4 pound per feet cube, or 9.81 kilonewton per meter cube. Okay, so 1000 kg per meter cube. But kg is mass. When you convert that one to weight, that becomes like 9.1 kilonewton. okay, because you multiply that one with 9.8 into 1000. So 9,800 Newton, which is 9.8 kilonewton, okay? So once you find that out, then basically you can find out from that unit weight of that if you know the GS, which means the specific gravity of soil solids, which is kind of um, a parameter you already kind of know, estimate that one easily, because for sand, this one is 2.65, for clay, this one is very close to 2.7, okay? And once you know the volume of solid and volume of water, you can just find out the volume of air by subtracting, like the volume from one unit minus VW minus VS, that's actually your VA. Once you know all that 5 parameters, then you can actually answer all the questions there. Now, the second way to do that one, like here, your unit weight is given. But if your unit weight is not given, but the void ratio or porosity is given, then basically you always take a diagram and the total volume would be 1 plus E unit. Means like actually you take such a way that your volume of the solid is 1, okay? So if the volume of solid is 1, then your VV is equal to uh, E equal to VV by VS, and VS equal to 1. So this one should be equal to E. Your VV should be equal to E. So the total volume from here to here is actually 1 plus E. Now you can just convert that one easily, that what would be your weight of solid. That actually like equal, because this is all know that 1 unit. So this one has to be actually equal to the unit weight of the solid, which is basically the specific gravity multiplied by the unit weight of water, right? By definition, your GS means like the specific gravity of soil solid is basically how many times more weight than water, right? So if it's GS is 2.6, this means like the weight of solid is 2.6 times the weight of water. So you can just get that one easily from there. Once you know the water content, you just multiply your WS with your W, so you get that one from there. And once you know the weight of the water, you just divide that one with the unit weight of water, and you can get the volume of water. Once you get all these parameters, then basically you can solve the problems. Okay, now let's see an example. Okay, not one, actually, I will show you 2 examples. One is with unit weight, the other one is with void ratio. Okay, so here is the question here. A moist mass of 1.1 feet cube of soil is 12.5 pound. If the moisture content or water content of the soil is 14% and the specific gravity of the soil solids is 2.71, that's actually GS, then determine the following: moist unit weight, dry unit weight, void ratio, porosity, degree of saturation, and volume occupied by water. And I'm just trying to say that follow the basic relationship to do this problem, okay? So here is your solution. First of all, you see this is given like for 1 feet cube of soil is 12.5. So what would be the weight for 0.1 feet cube is 12.5. So 1 feet cube of soil has 125 pound, right? 10 times. Because if you make 10 times here, that 1 feet cube, if you make 10 times, that becomes 125 pounds. Now, by definition, that's actually your moist unit weight. What is moist unit weight? It's nothing but the weight of 1 feet cube of soil. So you got your moist unit weight is 125 pound per feet cube. Now, since your unit weight is given, so you have to consider that figure, which the total soil is 1 feet cube, okay? So here, your volume is total is 1 feet cube. Now, your weight of the soil is actually total weight of that thing is 125 pounds, right? Now you can find out your WS first because you know the unit weight, 125 divided by 1 plus W. W is 14%, means like 0.14. So you can find out this one, 125 divided by 1 plus 0.14, so 109.65. That's the weight of the solid. So what is the weight of the water? You can find out two different ways. First of all, you can just subtract this one from there, then basically you can get the weight of water. You can also find out using this formula, which is W into WS, but again, you would get the same amount like 15.35 pounds. So if we add these two, that's actually 125 pounds, right? Now, once you know the weight of water, then basically you can find out the volume of water, just dividing that one with the unit weight of water. So you come here and you can divide the weight of the water divided by 62.4. So this is 0.25 feet cube. Similarly, you can find out the volume of that soil because your volume is weight of the solid divided by the unit weight of solid. So unit weight of solid is GS gamma W, means like 2.71 into 62.4. So if I plug all those values here, then I get my VS equal to 0.65 feet cube. So the volume of solid is 0.65 feet cube. The volume of water is 0.25 feet cube. Total volume is 1, so I can find out my VA is equal to 1 minus 0.65 minus 0.25, so this is 0.1 feet cube, right? So once I get all that 5 components here, then basically I can answer all these questions quite easily. Now let's move to the next page. Just for clarity, I am just showing you only the 5 parameters that we find out here, not the formula anymore. Now, let's say what is the moist unit weight? We already calculated that 125 pound per feet cube, right? Now, number 2, this one is saying is dry unit weight. What is dry unit weight? That's basically this divided by the uh, total volume. So actually WS by V, so that's actually 109.65 divided by 1. So this is basically your dry unit weight. Now, what is your void ratio? Void ratio is nothing but VV by VS. What is my VV? That's actually 0.1 plus 0.25. That's the total volume of the void, right? So that divided by VS, 0.65, so that's 0.54. That's your void ratio. Porosity. Porosity is nothing by VV divided by total V. So VV is 0.1 plus 0.25 divided by total volume is 1. So that's actually 0.35. Now, degree of saturation, that how much of that volume of VV is occupied by the water. So this one is basically VW divided by VV into 100. So 0.25, that's the volume of water occupied in 0.35, that's the total volume of void. So that's basically 71.4%. The last question is volume occupied by water. I know that's actually, we already saw that one here, like that's 0.25 feet cube. So that's 0.25 feet cube for 1 feet cube of soil. But actually I was given only 0.1 feet cube of soil. So if they ask like, hey, how much volume occupied in 1.1 feet cube of soil, that would be actually 0.025 feet cube of water in 0.1 feet cube of soil, okay? So that's the way we do this kind of problem when the unit weight is given. Now let's see the example problem 2 when your void ratio is given. Okay. So here you can see the void ratio of an undisturbed soil sample is 0.55 and the moisture content is 11%. If the GS is 2.68, determine the following: moist unit weight, dry unit weight, degree of saturation, and moisture content when the soil is fully saturated. And again, I'm trying to do that one following the basic relationship. So I want to find out all the 5 components there, and from there I want to answer these 4 questions from there. Okay. So since this void ratio is given, so I'm gonna take the figure, which is the volume is actually, total volume is 1.1 plus E, and this volume of solid is 1, and the volume void is E. So basically E is given. So what would be my Vs is 1. So this one has to be 0.55 feet cube, right? Equal to your E here. Then what would be the total volume? That would be 1 plus 0.55. So that's actually 1.55 feet cube. Now let's go here. If you try to find out the WS, that's actually GS gamma W. So 2.68 into 62.4, that 167.23 pounds. Now you can find out this one from here, which is just multiplied with your W, which is 11%. So if I just multiply this one with 0.11, then I get this one here. Okay, so I know this one, this one, this one, and only thing I don't know is the volume of water. But I know the weight of water, and I know that each feet cube is 62.4. So if I divide this one with 62.4, then basically I get the volume of water here. Okay. If I get the volume of water and I know the total volume is here, so or I can just find out my volume of air, either like total weight minus this weight minus this weight. So I get 0.25. Or I can just say like my VV. So if I take my VW from there, so I get my VA here. Okay, so now I know all the 5 components here. So these are all 5 components here. Now I can answer all the 4 questions from there. Now let's see. Let's say the first one, like moist unit weight, which is W by V. So my W equal to this plus this, right? This is my W divided by 1.55. So this plus this divided by 1.55. So I get 119.76 pound per feet cube. Okay. Now my dry unit weight, that has to be this weight of solid divided by the volume. So this one is 167.23 divided by 1.55. That's basically 107.89 pound per feet cube. Okay. Degree of saturation. So that's actually volume of water divided by volume of void into 100. So if you see my VW is 0.3 and VB is 0.55 multiplied by 100, that's basically 54%. Okay. Now the final question is weight of water when the soil is fully saturated. Very important question, like when this one is fully saturated, then what would be the weight of the water? So when this one is fully saturated, then basically the volume of water has to be 0.55 feet cube, right? All the void are filled with water. So if the volume of the water is 0.55 feet cube, then what is the weight of that? That multiplied by 62.4, so that would be 34.32 pounds. Okay. Now let's move forward that how we can solve this problem using the formula given. Okay. So uh, anyway, this one is also, I forgot to tell you that this one is also asking for water content. So water content is WW by WS. So if I know the weight of water when the soil is completely saturated, so 34.32 divided by weight of solid, 167.23, then multiplied by 100, so 20.5% water content. So when the soil is completely saturated, then basically the water content would be 20.5%. Okay. Now let's move forward and see that how we can solve these two problems using the formula given in your book. So if you go to your book, you can see the lot of formula given here. Okay. And you can understand that like you have to take your FE exam. Actually, you can only use your FE um, handbook. Okay, so they are not gonna give you this book so that you can open and just copy that formula over there, right? And it's very difficult to remember all those formula here. Actually, I see this one actually making you very nervous. Like when I see that page and a lot of formula here actually made that one, make that one, made myself very nervous, okay? So now, if I see here that this is basically your AFI reference handbook, they will give only this information here. You know most of them by the time that your void ratio is VV by VS, your porosity is VV by V, your degree of saturation. You already know that one, but one of the most important relationship given here is actually gamma sat, which is GS plus E into gamma W divided by 1 plus E. You have to remember this relationship, okay, for your FE exam. For here, actually, this one would be online exam, so I'm not going to proctor you like whether you're looking your book or not. So I cannot do that one right now, but I'm just talking about your FE exam. For your FE exam, actually, you have to remember that formula here. And not only that, you have to remember another three formulas here. If you remember these three, actually, you can solve all the problems instead of like this huge, like number of equations here. Actually, you only need these three equations, okay? So first one is AC equal to gamma GS. Many times we call that one Swig's equation. Swig's, just to remember that one. AC equal to W equal to gamma GS. And then you can see your gamma D is actually GS gamma W divided by 1 plus E. And you already know the relationship of your gamma is equal to gamma D into 1 plus W. So if you just plug that value of gamma D here, then basically you get your gamma is equal to GS gamma W 1 plus E into 1 plus W. So basically you have to remember Swig's gamma D equal to GS gamma W 1 plus E, and gamma equal to GS gamma W 1 plus E into 1 plus W. If you can remember that three equation, basically you will be able to answer all the questions, okay? Now let's see that how we can use that equation to solve the problem, the example problem 1 and 2, okay? So that's actually your moist unit weight, like that moist mass of 1 pound feet cube, zero point 0.1 feet cube of soil is 12.5 pounds. If the moisture content of the soil is 14 and the specific gravity of the soil is 2.71, determine the following: moist unit weight, dry unit weight, void ratio, porosity, degree of saturation, volume occupied by the water. Now we have to just do that one very easily. First of all, we already know that the weight of 1 feet cube is 12.5 pounds. So 1 feet cube is 125 pound. So your gamma moist by definition is 125 pound per feet cube of soil, right? Now, 2, what is dry unit weight? Dry unit weight gamma D is basically gamma divided by 1 plus W. So you can just find out 125 divided by 1 plus 0.14. That's actually your water content W. So you get that on 119.65. Now again, your gamma D is basically also, we know that formula G is gamma W1 plus E. So from that equation, if you simplify that one, then basically you get E equal to G is gamma W divided by gamma D minus 1. So if you plug all those values here, then basically you get your E from here, 0.54. Now you know the relationship between porosity and void ratio. That's actually also given in your FE reference handbook. So porosity is basically N equal to E divided by 1 plus E. So if you plug those values like 0.54, that's your E divided by 1 plus E. So you get your N equal to 0.35. Now degree of saturation. So we know that equation SE equal to WGS. So this is actually your saturation. This is your porosity. It's water content given. And your GS is also given. So you plug that value here. So basically you get your saturation is 0.7 or 70%. Okay. Now the volume occupied by water. So weight of water, that's basically gamma moist minus gamma D, right? That's the weight of water because that's the weight of solid, and this is the total weight. If you subtract that one, then you can get the weight of water per feet cube of soil. So that's basically 15.35 pound of water per feet cube of soil. If you know the weight of water, you can just convert that one to volume by divided by this one with the unit weight of water. So that becomes 15.35 divided by 62.4 is actually 0.25 feet cube. Okay, so that's the answer. You don't need any figure, you just use this equation and basically you can find out all the answers from your equations, right? So you can remember like these equations are given in your FE reference handbook. This is the one I said like, hey, you have to remember that one and you have to remember that one. This one is also given in your reference handbook. So these are the two I used here. Sometimes we might have to use the other one too. Okay, so that's only 3 equations you need to remember. Now let's see the second example problem, that how we can solve that problem using just the formula. So the void ratio E is given 0.55 and the moisture content is 0.11 or 11%. And the specific gravity of soil is 2.68. So determine the following: moist unit weight, dry unit weight, degree of saturation, and moisture content when the soil is fully saturated. So first of all, your moist unit weight is G is gamma W 1 plus E into 1 plus W. You can remember that equation, third equation, what we have to remember, right? So if you plug all those values, your GS is given, your gamma W is 62.4, E is 0.55, W is equal to 0.11. You just plug that value, then you get your gamma W is basically 119.76 pound per feet cube, okay? Then what is your dry unit weight? Dry unit weight is GS gamma W1 plus E. So if you plug all those values here, then basically you get 107.89 pound per feet cube. Degree of saturation, that's the third equation, actually SE, Swig's equation, SE equal to WGS. S is basically your degree of saturation. So your A is equal to WGS by E. So that's actually WGS divided by E. So you get 0.54. So your saturation is 0.54 or 54%. That's up to you that how you want to express that one. Okay. Moisture content when the soil is fully saturated. So here you can just use this equation again, like when your soil is completely saturated, then basically this one would be your, has to be 1, right? Fully saturated means like 1. So in that situation, what would be your W? Like water content, moisture content, right? So if you plug those values here, then basically you get your W is equal to E divided by GS, E divided by GS. So that's actually 20.5%. So you can see it takes, like, you can do it much faster here if you use this formula, okay? But I'll just recommend you to like practice both ways so that you can understand actually what's going on there. Um, but if you want to use that or prepare yourself for the FE exam, then basically you have to remember that 3 formula I given you here, this one, and this one. Then basically you will be able to solve most of the problems, okay? So if you have any question, please contact me during the office hours. Join me in the Zoom. I have a board here so I can show you um, and explain that one in much easy way than if you ask me a question in the email because I need to show you the figure and everything. So anyway, thank you so much um, for your attention. And if you have any question one more time, just feel free to contact me. Thank you. Bye.